Hi, can you hear me? Yeah, cool. First, I want to thank sponsors and organizers for inviting me again in Kiev. This is my third time here. It's amazing. I love the city, I love the people here, and I love to be here. So thank you for inviting me again, and I'm happy to see that conference is going bigger and bigger. Today I will talk about progressive web apps. So first, let me introduce myself. I'm Antonio. I'm from Split, Croatia. I'm the CEO at Locastic. I'm also co-founder of Blockada. We founded that this year, actually, and as far as I could understand from previous talk, I understand it's something about blockchain, and Blockada is a non-government organization that actually organizes 2 annual events in Croatia that topics is about blockchain. For last 10 years doing PHP development, and I'm using Symfony since version 1.4, so for last 8 years, I think, or so. And that's my connection to this conference, because I won't speak about Symfony today. About Locastic, we are based in Split, Croatia. We are around 23, 24 employees. We are working mostly on backend with Symfony, frontend React, Angular, and we are working mostly on custom development projects for clients from all parts of the world. The biggest project that we lately did was with API platform on backend and React on frontend. It was entire custom ticketing system for biggest bicycle marathon organization, which has franchise in more than 18 countries over the world. We are also doing some custom CRM systems and things like that, multi-vendor web shops. We are involved a lot with serious development also. This is few pictures of our team. And as I already mentioned, I won't speak about Symfony today. I will speak about progressive web apps. Progressive web apps are mostly about 2 things, I will say. They're mostly about mobile and about user experience. And this is very, very important, because we are living in a time when we are part of mobile revolution. So before I start talking about applications, let's see a few things about mobile revolution. So by 2020, more people will have mobile devices than electricity, and already more people has mobile device than running water. So basically, it's easier to find someone in the world who has mobile phone than anything else, basically. And if we see how much things we are serving to the mobile devices, we are already serving more than 50% to the mobile devices from entire traffic that we are doing on the internet. And in 2006, we already started to search more from mobile devices than from web and desktop devices. And if we see how much time we are spending on mobile devices compared to web, we are spending 87% on our mobile phones. Like, for example, now probably 10–50% of people is using mobile. And we are spending more and more time using devices. And when we are talking about user experience, I love these pictures and I love this graph. They are from Code Horror blog. And they say, like, user experience, if you have like big reward, user is like mouse on this picture here. So if you have like huge cheese, they will do anything to get that cheese, because the award is huge. But usually you don't have that much cheese, so you need to invest in user experience. You need to invest in things that your users can use your app more easily. Like, for example, in past probably we all used ICQ. Who used ICQ? And you remember how awful it is, of course. But we use it because we didn't have anything else. Today we have WhatsApp, we have Viber, we have much better apps with much better user experience. So basically we need to invest a lot in user experiences. And trust me, you will never have a huge cheese, like big enough. And this is the best quote from that blog, from the book. If you didn't read it, I will advise you to read it. It's an amazing book. It's how to be better developer, but without writing the code. And one of the topics is user experience, his user interface. And he said that he doesn't care about how much diagrams you have inside your documentation about your architecture in things. If you don't have proper and good user experience, that's nothing, because UI is the application. Today, I will focus on talking on progressive web apps. So before I start, I want to know how much of you is familiar with progressive web apps. Okay, few, and how many of you build actually progressive web app? So 1, 2. Okay, so if you didn't heard, like progressive web apps try to mix both from the both words. When I say both words, I mean mobile and web. We have simple graph here. This says what are capability of applications and say what is the reach of our application. In the web, we have huge reach. Like reach is maybe 3 or 4 times bigger than on mobile apps. But mobile apps has a lot of features that we cannot or we couldn't have or we haven't been able to use in the past. So what we want to achieve with progressive web apps is to keep that reach that we have and to add some other capabilities. So we want to have progressive web apps as the best of the both worlds. So if we want to have some simple definition of progressive web apps use modern web capabilities to deliver an app-like user experience. And I will repeat 2 more things. Modern web capabilities, app-like user experience. What does this mean? This means that with existing web technologies, we can build almost the same applications as native. So progressive web apps should be progressive. That means it should work for every user, regardless of browser choice, because it's progressive enhancement as a core tenet. It should be responsive, so it should adjust to any screen. It should be connectivity independent. That means it should work even without internet connection. If you ask how, I will show you later. It should feel app-like, so it means that user when user is using your progressive web application, she or he should have a feeling that he's using native mobile app. It should be fresh. That means always up to date. It's much harder with native apps than with progressive web apps. It should be safe. That means that everything should be served through the HTTPS. And this is the rule number 1 for the progressive web apps. If you are serving something from HTTPS, you probably won't be able to, not probably, but you won't be able to use, for example, service workers. It should be discoverable. That's the point of the reach. Like we used to Google and find something, and we can find our progressive web apps. It's much harder to find native applications. It should be re-engageable. That means once user installed your progressive web apps, you should be able to contact him in some way with some notification or something else. It should be installable. That means that we can add progressive web app to our home screen, and it should be linkable. That means same as the foundation of the web, we can share the link to our friends, family, or whatever, and there is unique URL for each resource on the internet. This is the core concept of the progressive web apps. So it's based on HTTPS, it's based on service worker, web app manifest. There are some optional things like push notifications and other APIs. We will talk about that a little later. For all things I told you already, we need to focus on 4 things actually. We need to make fast applications. We need to make integrated applications, and we need to make reliable applications. And of course, we need to make engaging applications. I will start first with the fast applications, and that means that we should not have junky scrolling. We should not have slow load performance. We should measure what's happening with our applications and improve all the time. And bad connection is not excuse for anything, is not excuse for bad performance. So if we take, for example, the statistics, the 53% of the users will leave our web apps if it takes more than 3 seconds to load. And now when you are thinking, you may be thinking like 3 seconds is not much of time, but I have demo, so you can check it here. Like check it on the right side, and you will see that this 3 seconds means like forever if you compare this for less than a second. And in that 3 seconds, you will lose half of your users or visitors or customers, whatever. So this is really, really very important thing to notice. And on the left side, we have progressive web applications that is loaded in less than 1 second. How to do these things? Like if you're starting to build applications from the beginning, you should use app shell model. The single page applications use this. So basically you cache everything that is part of the view on your client side, and then you are just sending the content from your web servers. So of course you need to have quick APIs, but this is very simple model to build. An app shell model allows us to have reliable performance, native-like interactions, and economical usage of data. If you are on 2G or 3G connections, or even on edge, you want to save a lot of data to have faster delivery to the end users. Next thing that I want to focus on is integrated applications. What that means? That means that users should work with your application in the same way with any other application that he downloaded from the Google Play or App Store. So there should not be any difference between usability of progressive web app and native mobile application. Users should be able to download that application to the home screen, to start it from the home screen, and to use some additional things like camera, like location, like payments, and things like that. Okay, let's start with the home screen. Like this is the center of basically our universe. Like every day, approximate 80 to 100 times per day, we take our mobile phone, we open the home screen, and we use Twitter, Facebook, or whatever. So you probably all know what is this, especially the female part of the here. This is the Zara application. So usually girls have this application installed because it's a huge brand, they are crazy about that. They will download that application and they will have it on a mobile phone. But this is our client from Croatia. Nobody knows about him. He is selling pretty good on the web, and he doesn't have any ROI to invest in mobile applications. He will need to build 2 applications, he will need to maintain them and things like that. But maybe the progressive web app is a solution for him. And if we track the statistics, and there is the questions again for you, like if you installed like one application in this month, can you raise your hand? 2 applications, 3. Okay, we have 2 people, I think. So basically, this is the statistics. Nobody installs the application. Like if you are usually installing this kind of applications, YouTube, Facebook, Twitter, but that's basically it. You have already Gmaps, you add Instagram and something like that. And you can see by the age, there is no difference. We are only installing the social applications. And there is one more fun fact. This is the funnel of downloading the application. So if 1,000 of people starts to download the application, 80% of them actually forgot about that application. Like when they load, it's 800 already. Find in a store, 640. The 1,000 is the number of the people who intended to install your application. Accepts permission, we are already lost 60% of our users. Download waiting, and they forgot they installed the new application. So only 250, 25% of the people will use your application after they download it from the store. But 80% of the users intentionally move apps to or from their home screen. Why? Because it's easy, or they like the icon. That's like true. If the icon looks good on your home screen, a lot of people will keep them. We already before the progressive web application, it was possible to add a website to our home page, but the experience was off. You can see on an image there, like you need to go to the menu bar, you need to find it to the home screen, you need to write a name, and you don't know where that application will take you. Probably it will open the browser, it will take you to some page which you bookmarked, same as a web browser works. So for example, if you bookmarked the picture of your friends in Instagram, you won't go to the home page of the Instagram, you will go always to that picture. You don't have a clue will that work offline or not. And the most important thing is that requires a lot of user interactions. And we want to do that simple. We want to be that one click. So web manifest is something new from the progressive web apps. It's simple JSON file which tell browsers how to interact with our application. Having manifest is required to add progressive web app to the home screen. There is manifest validator and manifest generator. You can use that, but manifest in base is just JSON file. It tells us what's the description of our application, what is the name, what is the short name, what are the icons that we are using, what is the scope, what is the base URL, and other things. And you can check that in developer tool in Chrome, like how your manifest will work. This is the same. I took the Twitter manifest and I just debug it here. And this is the thing that you need to add. This is the basic thing that you can add to your application, and you can add it like right now. In any existing application, you can add this. It's background color, it's a display, it's a name and short name. Short name is for your home screen, and name is when you are asking user will he install your application. Display, how application will be open. Theme color, how the application will interact with the mobile in way of colors, and background color is the starting dashboard, which color it should be used. So what is criteria to installing the application on your home screen? The app is not already installed. It must be served from the HTTPS. It should have registered service workers so that you add offline support to your application, and it should have this short manifest that we already saw. And once all the criteria are met, Chrome will fire before install prompt. So you can hook on this event. You can do some other logic. As you can see, we are adding listener to before install prompt, and then we can do some other things with adding to the home screen or not. This is little extended code, but do the same. Like once we want to ask user to add to the home screen, we will fire that event. Usually the best practice is to not interrupt user. Like if he's posting the picture on a Facebook, you don't want to interrupt him with hi, do you want to add these applications to the home screen? But when you see that he's using for the certain time and he's not in middle of any action, you can ask him. How it works, it's like this. It's very simple actually. You go to some website, you open the website, you do some interaction, and you get add to screen message, you accept that, and you have that on your home screen. This works also for desktops. So you can add Chrome applications to your desktop at the moment. The interaction rate from the home screen is 40% higher than if you don't have app on your home screen. And then we can go back to the client from Croatia, which I mentioned. Like maybe progressive web apps is the good solution for him, because he doesn't need to invest a lot of money in a project, but he still can have good mobile user experience. Second thing I want to talk about integrated experience is web payment API. So 66% of the purchases that we are doing on the web are done on the mobile. So we are surfing, we are buying, and things like that. But only 1/3 of conversion is done over mobile. So 2/3 of the conversions are completed on a desktop. That means that we have something broken in user experience. And the reason is that because checkout forms today are manual, are tedious, are slow, and we need to do end clicks. So usually the checkout process looks like this. You need to enter address, you need to pick up the shipping method, to enter again your address for shipping methods, to enter credit cards, to select payment methods, and things like that. Yeah, like you need to spend 50 minutes to buy something. We can improve that with autofill options, and this is very easy because you just need to add an attribute to your forms, and then from the browser information, this form can be autofilled. This is 30% faster. It's in one way automatic. It's it's still slow, but it saves us like 30% of time. Then we go to the web payment APIs. So what is the idea with web payment API is to have one payment API there where we can, with one click, pay our order. So it looks like this. It should work both. Yeah, I will say later why it is not working yet. But the idea is to work both web and mobile. So on one click, you will complete your purchase. How it works? Site calls payment request. Browser shows the UI to the end user to collect payment informations, send that payment informations to some payment gateway, collect the response and service to the user. It's quite easy actually to use. You just need to define your payment methods in simple JavaScript file. You need to define your payment options. Do you need shipping method? Do you need what informations do you need? And then you need to issue the payment request. Once you issue the payment request, actually created the payment request, you need to call show method. And that looks like this. Like when you call the show method here, the small pop-up screen goes to your screen, and with one click you are sending the payment. So all the information about your credit card, address and things are stored into your browser. Don't be afraid of that, because you are already probably storing informations to your browsers, including address, payment cards and things. And this is the payment response. Basically, it's just JSON file with some informations, and this is what's the summary of Web Payment API. It's automatic, it's simple, it's fast, it's one-tap click, and you can interact with other payment systems like Google Pay, for example. In this video, you can see how it works. So, it's shipping address, it's just one-click pick, it's a summary, and then it will be just pay. And you need to enter CVC code, confirm the payment, and that's basically it. So you don't need to enter anything manually. This is very quick, and this will probably increase conversions on the mobile and on the web, like I cannot even imagine how much. We have other APIs to integrate with our mobile device, like Media Session API. You know that on native apps you can change the songs without being in a browser. Now that's also possible with web applications. Or sharing. Usually we used a lot of third-party tools to share something on a Twitter, Facebook, contacts, whatever. Now we can integrate that with our mobile device and share that in native way. So as you can see, all progressive web app features are based on HTML5 APIs. There is no anything like PhoneGap in past or something like that. It's all there, and we just need to start using that. And remember, users expect to be able to interact with your app in the same way as they are interacting with their device, with other applications on their device. Third thing to talk about is reliable. And this is like maybe the most important thing of progressive web apps. What that means? That means that in any situation, you should not show your users that they don't have internet connection. Because we got used, when we are using our mobile phone, we don't have offline pages. We always have some data. If you open Facebook without internet connection, you will have some data. If you open Twitter, it's the same. So, and you know what this Li-Fi, when you have internet connection but it's not working, that's also not an excuse. So what's the reasons why we have in 21st century the bad connections or no connections? Because maybe we are in a tunnel, maybe there is power outage, maybe, I don't know, there is plenty of reasons. Maybe we are traveling to some zone which is not covered with internet connection. There is plenty of that zones in Croatia on the islands. So it could happen, and you need to be ready and prepare for that. We need instant loading offline. 60% of mobile connections is on 2G still. And when we are talking about 2G, it's not that we are talking about Africa. There are some parts from United States which are still using 2G. And there is average site of website loading on a 4G is 40 seconds today. So we are not optimizing websites for mobile at all, I will say. And 90 seconds is average on 3G. So we definitely need to invest some time in optimizing the mobile experience for our users. So we have service workers here. And service workers are like JavaScript proxy server between our web server and our browser. They are running independent from the browser and as a thread on operations system, and they can interact with any request that we are doing to the web server or locally. This is maybe a better picture because we can see that service worker has some cache API, and they can give us the offline experience for the users. So What we can do with the server workers? We have rich offline experience, I already mentioned that. We have background synchronization, we can push notifications, and many, many other things, and some things are not even implemented. But we will talk about mostly about rich offline experience. So service workers are running in the background, separated from the web page. I already told you that. They are separated thread, so if your web browser is closed, you still can interact with your service worker. It cannot access to the DOM because it's a JavaScript worker, and it's programmable network proxy. It is terminated when it is not in usage, and restarting when it is needed. So that means that won't drain our battery, or it doesn't take any memory resources or things like that when we are not using the service worker. And service worker is second load. What that means? That means that on the first request, our service worker is still not working. So on the first request, we will require something to cache, and then on the second request, that will start working for us. So this is the life cycle of every service worker. At the beginning of when you are loading the page, there is no service workers, and then you are installing that. There is the first install event, which we can use to cache, for example, CSS and JavaScript files. After the installation is done, we can get two situations. One, there is some, for example, if we are caching some files, and if some file is missing, we will get error, and our service worker won't be installed. You can see that error means completing. Once it is activated, it goes to idle state, and he's waiting for some notification, for some events to happen to start working. For example, it can wait for fetch event when the server is when a user wants to fetch something from the web server, and it can do some caching. We will see a little bit later. You can see here that can fetch messages. Okay, this is how we register service worker. So if service worker in Navigator, that means that our browser is supporting the service workers, and then we just need to add two listeners, load, and we need to call service worker register some service worker. If everything is okay, our service worker is registered. If it is not, we can log our message that service worker is not installed properly. And you can check again in your Google console, how is it installed properly, is it running, is there any problem, and some other things. On install, usually we want to cache our, for example, app shell. So we will define some name for the cache, we will define URLs to cache, and we will say our service worker cache that. On some other request, it won't be requested from the server, it will be served directly from our service worker. This is how it works actually. So on the first request from the service worker, it goes to install event. After install event, it goes to the network, and then we can save to the cache or load something from the cache. And then the service worker starts to work, and there is event activates, sorry. And this is how we catch and return requests. So we are listening for fetch event, and then on a fetch event we can return something from the cache, or if that not exists, request from the network. And if we check our network log in a Google Chrome console, we will see that the projector is not very well for this small font, but this says here it's loaded from service workers, not from the network or any other cache. We have few events for the service workers: on install, with dependency, without dependency, on activate, on user interaction, state while revalidate, on push message, on background sync. If we are updating the service worker, we need to change JavaScript, we need to deploy it to the server, we need to notify user that we changed that JavaScript so that he can download it. But the most important thing is that if you remember the life cycle, after the install, we are still using the activated one is still the previous one, not the new one, because we need to refresh. The server workers work on a second request. So we can skip that by calling the method skip waiting, and then our new service worker will start to work. On user interaction, we can do something like this. So when user clicks something, or for example, there is button on your application saved to offline, you will request that from the network, and you will store that to the cache. Later, when your user is not connected to the internet, you can serve that directly from the internet connection. And this is the code for that. So basically, open the cache, fetch the article from the web server, and serve it, and after that save it to the cache. It's quite easy. The API is easy. I'm not saying that service workers are easy, but the APIs that we have for them are quite straightforward. We also have this on network response. It's ideal for frequently updating resources, say, for example, user inbox or article contents. It's also useful for non-essential content such as avatar, but care is needed. So we will fetch something from the network, we will store that to the cache, and we will serve that to the user. That's the same as I told you before on the user interaction. And later, if the user is offline, we can respond them from the cache. We don't need internet connection for this case. Also, we have background sync, which there is no any interaction with the user in this case. But for example, when we send the push notification, we know that the user is online, that he can access to data on his server. So basically, when he received the push notification, we can trigger some background synchronization. For example, load the content to the cache that he needs to access via push notification. And later, if he doesn't have the connection and he clicks on your push notification, he will see that content because it will be served from the cache. And this is the code for that part. We have different serving suggestions, different caching strategies when we are talking about service workers. So we have cache only, network only, cache falling back to network, cache and network race, network falling back to the cache, cache the network, generic fallback, and service worker side templating. Cache only is the simple one, so you always respond with things from the cache. There is no interaction with the network, and this is how code looks like. So on a fetch, you will just respond from the cache. If there is no data in a cache that you are requesting, there's probably some console log error will be shown. We have also network only. So basically, we don't request anything from the cache. It's the same code, just we are using fetch instead of serving from the cache. We have cache falling back to network, and this is a great thing for building the offline first. For example, if the previous talk was about blockchain. So for example, if you are doing the trading with blockchain graphs, you want to serve always some data to the user. So you can save the data, you can serve the data from the cache, and later when network is updated, you can update that cache. But that's little more complex data. We will see that later. Complex example, we'll see that later. Actually, here is only if the cache is not available, we will request that from the network. And this is the code. So we are trying to get something from cache. If cache doesn't not exist, we are just fetching from the web server. Network falling back to cache is the same thing. The only issue with this is that if you are on a slow connection, if you are on Edge or 2G, it will take like forever for your user to get some requests. So actually, cache and then network is much better solution for that kind of applications. What we will do here? We will do here that we will serve the data from the cache to our user. Then we will update data from the network, update the cache, and serve the new data to the user. So that's the example of the, for example, trading with the blockchain. You will show, for example, last price of the Bitcoin, and then you will update it with the new price from the some API and show the new price, of course, store that to the cache. The code is still simple. So what we are trying to do, this is some function that will fetch the data from the server, and we try to get data from the cache. If that doesn't work, we will just have here the if statement. If the network data is not received, if the network data is received, don't update the page, because we don't want to override the network data. And of course, if there is no cache or there is no network, we will still show the cache to the cache data to the user. And cache the network, it's pretty much simple code. And good user experience, for example, is this from Flipkart. When you are online, your application is blue and shiny. But if you go offline, your application is gray, and you get the notification you are offline here, but all the data that you fetched and that you stored in your cache, it's actually in the color, so that you know which product you can click. You saw that we are doing a lot of code that is repeatable here, and of course we have library for the service workers. It's a workbox, and it's pretty, I will say it's pretty easy to use. So some conclusion about reliable things is that you need to provide user integrated experience with mobile device, so that can use your progressive web app as any other application they are using on their mobile stack. And you need to inform them about changes. So this is the good thing. Like, they are online, once they go offline, inform them about that, and that's the good user experience. And your goal is to provide that kind of experience, and connectivity is not an excuse. Fourth thing that I want to talk about is engaging. And engaging is that what makes our progressive web apps or mobile apps charming and attractive. For this thing, we need to shift our mind, how we are thinking about web patterns and how we are thinking about native patterns. We should start thinking more about native patterns. We don't want to have push notification for everything, like I had a new blog post, I posted a new picture. Like, notification should be precise, timely, and very, very short. So we have push notifications API, and on web, this is built with web technology, it looks like this. So you will need to allow push notifications, and there is one trick. Once your user block this or disallow you to send push notifications, you cannot send him a request for push notifications. So be careful with that, because then he needs to go to the settings of the browsers, find that, and allow the push notifications. So usually you should pop up with your custom confirmation pop-up screen and ask him, do you want to allow pop-up push notifications? If he says yes, then serve him from the push API request to allow that. And this is like funny picture about push notifications. Like, for the user, sometimes they are really annoying, but they won't turn them off because they are addicted to their push notifications. They have feeling that they will miss something out. And this is what good notification is. It's timely. I feel I need it, and I need it now. Precise, specific, exact info what happened and why that is important for me. And personal. It needs to be personal. It needs to be related to you. And this is an example of good notifications. So, for example, this is for travel media and retail about some discounts, which you may be interested in. There is notification about flight, about Uber that your car is arriving, and for Tinder that you have a new match. How this works? This works in the same way as push notifications for mobile phones, native applications. You need to have backend server that will send your message to some message queue or push message provider. For example, you can use Firebase. Then Firebase server will contact the service worker, and service worker will notify you on your mobile or web application. You can use push notifications also on a desktop. You probably noticed that on a Facebook or Twitter. And of course, we cannot communicate it this way, so we cannot send any data from the Firebase back to our, in this way, to our backend server, but we can hook on events, like we have new push event, and then we can send to our server like notification is delivered or user clicked yes or no or something like that. So this is again based on service workers. Service workers are listening for the push message. Once the push event is triggered, he will deliver the notification to the user, and he can do any request to our server, cache, or whatever it needs. This is how codes looks like. So for example, if we have the notification which is new mail, we can open the cache, save the email from our server to the cache, and once user click on a notification, we will serve them that to the cache. Notifications can have options like should it vibrate or should not, what's the title, what's the description, and it can have actions. This is the example with actions, yes and no. So you can have push notification on your mobile phone with actions, yes or no, also on a desktop. And the good thing about push notification is that 43% of the users usually accept the push notifications. And I don't know any website that has opt-in 43% for the newsletter, for example. Credentials API is standard-based browser API that provides programmatic interface between site and the browsers to seamlessly check in across devices. So if you, for example, logged in on website and then you are using mobile application or mobile progressive web app, you should be able to log in with one click. So it removes the friction of the sign-in flows like entering username and password. For example, on iOS it's quite easy now because you have keychain and you can store all the passwords and you can log into any website literally with 2 clicks. But this goes even forward because you will get just small pop-up and you will click and say, okay, that's my account. It looks like this, and pop-ups look similar to Google login. Okay, some tools that we can use for developing progressive web app. Actually, there is one tool that is most popular one. It's a Lighthouse, and there is Lighthouse as web service, and there is also Lighthouse as extension for Chrome browser. So I took my Chrome browser and I do the Lighthouse auditing on a conference website, and this usually takes about a minute, but this is fast forward video, and we will get some scores. We will get scores about progressive web app, about performance, about user experience, about accessibility, about SEO. And this is how a report looks like. You get, like, it's not idea to show, like, by example, I usually, when I'm at the conferences, take the conference web page, and of course the conferences web page are not built as progressive web apps, but the idea to show here is that you get some ideas what you can fix to get your app faster, to get your app more useful, to get your app more progressive. And you can easily debug your application with this. Also, you will probably never have 100 scores, but like put everything in a green, it's pretty much okay. Some showcases. Twitter Lite application. Twitter wrote progressive web app, and there was like tremendous increase in page per session. They got 65% increase in page per session, 75% increase in tweet sends, and 20% decrease in bounce rate. The application was like 20, 30 megabytes, something like that, and it was almost the same experience like native app. Alibaba has 76 higher conversion across the browsers, 4x higher interaction rate from ad to screen, and increased usage of native apps also. So people, after starting using progressive app, also wanted to use native app and start downloading and using. Book My Show, 50%, actually 80% in conversion rates, 54% smaller than Android app, and 100% smaller than iOS applications. And also there is huge saving data that progressive web apps are consuming comparing to application. And again, Tinder is impressive progressive web app. So there is huge, here is the link on the slides, there is the huge use case how they build the progressive web app. The optimization they did is amazing. And they had load time almost 12 seconds. They reduced that to the 5. And the app is 90% smaller than native builds. So that's like really, really impressive. And in this use case, in this case study actually, they are talking a lot about how they build, how they improve performance, how they optimize the things. Also, Uber has progressive web app, Lyft has it, Google Maps are built with progressive web apps, and so on. Some myths about progressive web apps. Progressive web apps are only for offline apps. We saw in examples that that's not true. because we can use push notifications, we can use payments and things that we are not using with offline applications. But progressive web apps in combination with service worker finally give us chance to serve data offline to our users. Progressive web apps are mobile thing. Again, it's not true, because progressive web apps increase the user experience of web applications also. And the funny thing, people always think that progressive web apps are Google only thing. That's again not true. And the funny fact is that idea about progressive web apps was from Steve Jobs. Actually, it was from the Microsoft in 1990 something. But when he presented the iPhone 3, I think, he said that he want to have like web applications that works perfectly on a mobile and interact with all features that mobile had. So actually that was progressive web apps. Of course, why we are thinking that's a Google thing is the reason because Google Chrome team invests a lot on promoting and developing new features for progressive web apps. And the thing that progressive web apps are not ready yet. This is something that I agree with partially, but still we can benefit a lot from progressive web apps. On a slide you show that loading is below 1 second, and on regular mobile website is almost 3.3 seconds. So you should take the best you can from the progressive web apps and use it for your mobile experience. This is the situation today. So almost all major browsers are supporting service workers, but still it's not like perfect experience that we are expecting from the progressive web apps. I will say that in that way. Second thing is payment request API. There is no browser that actually support that in production already, but they are doing a lot of research, and we have candidate release in a W3C standard at the moment. Regarding push API, we see that Edge, Firefox, and Chrome supports it, but Safari doesn't support that. And I need to say that Microsoft with Edge is really pushing things really good. So you can, the Microsoft is the only store at the moment, I think, where you can submit progressive web app directly in the store. Google supported that, I think, but they removed. I don't know why. And Apple never supported for now. And web app manifest, as you can see, it's fully supported only on the Edge. It's partially supported on a Chrome, and it's not supported on a Safari. If you want to play with progressive web apps, this is a great page where you can go and see what is possible to build on. There is like huge things, including virtual reality and things like that. And this is the situation today, like what is possible to do with a browser. As you can see, there are push messages, offline mode, geolocation, online state, vibration, battery status. There is a lot of integration with hardware of our device. But still some things are not possible. For the end of this talk, I have one video which compares progressive web app and native app. So I will play it now. As you can see, some things are faster on progressive web apps than on the native, but also it depends how the apps are built. But I just want to show you that progressive web apps can work perfectly almost as native mobile application. It was not idea of the video to compare the speed, but okay, installation is much faster with progressive web apps and things. And to conclude this talk, what I want to advise you is don't be driven in any kind of development, don't be driven with the hype. Like, try to choose what's the best fit for your project. And in this situation, really, it's not about progressive web apps versus native apps. It's about users. It's about customers. What's the best for them? What's the best for your clients? And how you can, with, of course, as with their budget or with less money spent, how you can build perfect user experience. And progressive web apps, I think, can push the web to that direction, and I hope that will happen in next few years. Thank you.
У кого-то есть вопросы?
And once again, can you show once more how to add the app to the home screen? So I'm check your several examples, and no way I find out the way how.
Which phone do you have?
X iPhone.
It's not possible.
Oh,
That's the problem. I think the biggest reason why is that not possible is the money, actually. Because if that is possible, there is a huge amount of application that you wouldn't ever apply to the App Store. So it doesn't work still on an iPhone. You can see, just a second.
So as Apple blocks this one to this features, yeah?
I think they will allow that features because if user requires them. This is the status of web app manifest. As you can see, it's not. It's planned to be supported, but it's planned to be supported for last major 2 releases. From the version 11, they started to support some features of the progressive web apps, like service workers, but still it's not supported. That's the problem with the iPhone still.
Okay, what about browser support? So you said about X. You show the Chrome. Chrome is like an edge to implement all features, yeah. But what about Safari? Firefox?
Safari and Edge are going pretty fast forward. So they are implementing a lot of features, or they already announced to implement it. As you can see, for example, in the slides here, Edge is always green or half green.
I see.
It's the same with Firefox. The major problem is Safari at the moment.
Okay, another one question is about service worker and store privacy data. Is about that. For instance, if I try to cache in, the user currently is logged on. So for instance, I was logged on, and connection is dropped. Like I'm going to the tunnel, yeah. For instance, I'm not available some while, but I, for instance, try to make fill the data for payment, and next I'm going back to the coverage of the network. Or for instance, I'm still not in the coverage. Have a way to store the data about the user in the cache of service worker?
Usually not. You should store that to the local storage of your application. That's something what we do. In a cache of service worker, you should not store any states. Not about users or about anything. Only the information about like.
So it's just static cache.
Static cache, yeah.
Hello, thank you for the speech. The question is, what would happen if a user purchasing some goods while the application is offline, and then user closes the browser? What would happen? Would this purchase?
That depends on you, actually. Like service workers are quite powerful, but in the end, everything depends on developer. How do you want to build your application? So basically, you cannot process some payment offline because you need to conduct some. The payment API, I didn't mention that, but the payment API is not one. It's not payment provider. It's not new Apple. Or, sorry, it's not new PayPal or something like that. It's just API to connect to something like that. So basically, you cannot do anything offline because you need to contact some payment service provider and you need to get the answer. But you can, like, I don't know, probably you cannot do anything if you are offline.
So,
regarding the completing the payment.
so the payment would be processed when he opens the application next time.
Yeah, you can, for example, store. You can store that, like that he attempted to complete that, and once you are back online, you can notify your server and then send him the push notification, like you can complete the payment now, and you can prepare everything for him. That will be, I think, the perfect scenario for offline.
Okay, thank you.
Еще вопросы? Thank you, Antonio. Ребят.